If we are to have an honest conversation about the state of the automotive industry in 2026, we must start by dismantling a lie that has persisted for exactly 140 years, since the first internal combustion vehicles rolled out of German workshops. The fundamental interface between machine and road has remained at its core, primitive. We have been sold an illusion of advancement by brands like Mercedes-Benz, Bentley, and Rolls-Royce, cloaked in seductive marketing terms like magic body control or active ride. But strip away the leather, wood, and soundproofing and examine the raw mechanical engineering, you find a system functionally identical to a Victorian horse-drawn carriage. We rely on a passive system, a steel spring to bear weight, and a tube filled with oil, the damper, to stop that spring from oscillating indefinitely. For a century, engineers have, in effect, gaslighted us. They declared this lag unavoidable. They insisted the trade-off between ride comfort and handling precision was an immutable law of physics. They told us you could not have a car that handles like a Formula One racer and rides like a hovercraft. They lied. The truth is, the solution was identified decades ago. In the early 1990s, the Williams Formula One team developed the FW14B, a car with active hydraulic suspension so dominant it was banned by the FIA for being too effective. It proved that active ride height control granted monumental aerodynamic and mechanical advantages. Simultaneously, Dr. Amar Bose, the audio genius, spent 30 years and hundreds of millions proving electromagnetic motors could replace dampers entirely. His prototype Lexus could jump over obstacles and corner with zero body roll. The automotive industry killed the project. It was deemed too heavy, too complex, and crucially, too power-hungry for the 12-volt electrical systems of the time. The giants of Germany and Detroit looked at the future, shrugged, and returned to polishing their antique hydraulic valves. They chose incremental evolution over revolution, betting the internal combustion engine's low-voltage electrical system would rule forever. They were catastrophically wrong. This brings us to the technological rupture of 2026. BYD, a company that began making mobile phone batteries in Shenzhen, has picked up the baton Western engineering dropped. With its Yangwang sub-brand and the DiSus, or Intelligent Suspension System, it has mass-produced the linear electromagnetic suspension. We must be surgically precise. This is not air suspension, which is merely a rubber balloon replacing a steel spring, still governed by slow gas movement. The DiSus eliminates fluid and gas entirely. It is a dry system. At each corner sits a three-phase linear electromagnetic motor. Imagine a high-speed maglev train compacted into a cylinder within the wheel arch. Apply an electrical current, and it generates pure force, not pressure, at the speed of light. The critical number defining this revolution is 10 milliseconds, the system's total reaction time. For perspective, the human brain takes 200 to 250 milliseconds to process a visual threat. A blink lasts 100 milliseconds. The DiSus system, reading the road via LiDAR and sensors, calculates the required force vector and physically moves the wheel 20 times faster than you can perceive a bump exists. This enables the real-world application of skyhook theory. The car body remains fixed in space, perfectly level relative to the horizon, while the wheels articulate furiously underneath. Mechanically decoupled from the chassis, the motor can extend a wheel into a pothole and retract it before the shockwave transfers to the cabin. It effectively erases road topography. Furthermore, it demolishes the unsprung mass myth. For decades, purists argued bolting heavy electric motors to wheels would ruin handling, as inertia would overwhelm passive springs. But DiSus is active. The motor is powerful enough to manage its own mass, accelerating the wheel downward at rates exceeding gravity, 9.81 meters per second squared. Forcing the tire into the tarmac to generate grip where none existed, it transforms the suspension from a shock absorber into a downforce generator, creating a level of road connection no mechanical spring can replicate. If the Yangwang U9 luxury sedan represents the refined application of this tech, then, well, the Yangwang U9 supercar is its weaponized incarnation. Featuring the DiSus-X system, it showcases the potential of an 800-volt silicon carbide architecture. The U9 suspension has a peak power output of 36 kilowatts, more than the entire drivetrain of a small city car. And, the viral footage of the U9 jumping isn't some carnival trick. It's actually a demonstration of insane power density. For a 2.5-ton vehicle to leave the ground, the motors must deploy explosive force instantly. But the real revolution isn't the jump, It's safety. The U9 can execute three-wheel drive. In a traditional supercar, a wheel disintegration at high speed leads to a collapsed suspension, grinding chassis, and honestly, a fatal spin. The U9 sensors detect the loss of vertical pressure in milliseconds. DiSus-X instantly retracts the hub of the missing wheel, lifts it clear, stiffens the diagonally opposite corner as a fulcrum, and uses quad-motor torque vectoring to keep the car straight. It basically turns a catastrophic mechanical failure into a manageable event, and the ultimate mechanical redundancy. This proves the analog feel of European supercars is, in part, a lack of active safety systems. The comparison is brutal. The Porsche Panamera's excellent 48-volt active anti-roll system can twist a bar to mitigate roll, but it cannot lift the car, jump, or drive on three wheels. The 48-volt system is a toy next to the 800-volt sledgehammer of DiSus-X. BYD brought a nuclear weapon to a knife fight, and legacy manufacturers don't yet realize the battle is over. We cannot ignore the third pillar. DiSus-P, found in the Yangwang U9 off-roader. While the DiSus, which uses linear motors, and DiSus-X systems prioritize speed, DiSus-P uses intelligent hydraulics for immense power and travel. It rivals the best from Land Rover and Toyota, but functionally destroys them. It is the world's first intelligent hydraulic body control system, with concurrent three-axis control, replacing mechanical anti-roll bars with linked hydraulic chambers. On-road, valves close to stiffen the chassis by 200%, eliminating body roll. Off-road, they open to allow 155 millimeters of independent wheel articulation. The utility is just genius. The pumps are so powerful the U9 can perform an emergency float mode. In deep water, it seals the cabin, raises the suspension to reduce drag, and uses spinning wheels to propel itself like a boat. It can even execute a tank turn on its own axis. Practically, if you get a flat tire in the desert, the suspension can lift the damaged wheel high enough to change it without a jack. This is not just luxury, it is survival engineering. We must also examine the thermodynamics of this revolution. For a century, suspension has been a parasitic system, wasting kinetic energy as heat dissipated into the atmosphere. The DiSus and DiSus-X systems are fundamentally different. They are generators. As magnets move through coils, every bump induces an electrical current. On rough surfaces, the suspension harvests energy, feeding it back into the high-voltage battery. This is regenerative damping. While it won't fully recharge the car, it significantly offsets the system's power consumption, turning rough infrastructure into marginal range gains. This closes the energy loop, solving the efficiency problem that doomed the Bose project in the 1990s. The car becomes symbiotic with the road surface. The worse the road, the more energy it recovers, a level of integration impossible for internal combustion vehicles. Culturally, this marks the death of the chassis tuning guru. For generations, brands like Lotus, BMW M, and Porsche relied on master engineers testing thousands of springs, shims, and bushings to find a car's soul, a black art. The DiSus system renders this obsolete. The feel of the car is now code. Stiffness, rebound, roll characteristics, all are defined by software variables. This means the suspension can be updated over the air. You can download a track mode that mimics a GT3 car's stiffness, or a Comfort Plus mode that floats like a 1970s Cadillac. The hardware is static, the personality is a download. The soul of the machine has migrated from metal to silicon, allowing BYD to iteratively refine handling based on global user data. Something a mechanical suspension can never do. This leads to the hard geopolitical truth of 2026. The era of mechanical excellence is over. We have entered the era of the software-defined vehicle. For decades, the West comforted itself with the belief that China could only copy, that Chinese cars would forever be cheap alternatives with poor dynamics. The DiSus ecosystem proves this era is conclusively over. BYD has not merely caught up, it has innovated a technology that renders the entire legacy of European chassis engineering obsolete. For consumers in the US, UK, and Australia, the question is no longer, is a Chinese car good enough? It is, why am I paying $100,000 for a German car with Victorian suspension technology? The road didn't get smoother. The machine just learned to conquer it. The revolution is here, and it is silent,